Welcome to 6.2, Congruent Angles. Okay, before we jump in and start doing proofs with angles, I want to have you just compare your notes here for a minute. This section and the previous one are similar. The proofs in this section use the same general approach, but they involve angles instead of segments. So congruent angle statements are switched to measures, and some arithmetic or algebra is performed, and then the statement is switched back to a congruence statement. So it's important to remember congruence describes the set of points, while the angle measures are real numbers. So remember, that's the primary difference between equality and congruence, and so we have to be careful when we're using our statements and reasons that we're doing the proper scenario here. Okay, so let's go ahead and jump right into an example. Okay, the only way that you get good at proofs is by doing them, and we're going to be doing 3 different theorems we're going to prove in just our notes today, and I'm going to give you, once we prove those theorems, you'll have them. You'll have them to use. I'm actually going to have you do half a proof for your WISC summary along with a couple other little exercises. So, okay, so example 1. Prove that all right angles are congruent. So if you notice, it's not spelled out for us, a given and a prove. Okay, so when we look at this, they didn't give us the given in a direct way, so we have to know right away that we have right angles, that we're starting with right angles. So that's going to be our given. Alright, another thing that we really need to do, and I think this is good for no matter what proof you're trying to do, is draw or sketch a picture. If you don't know what you're doing visually, it just helps map out kind of your steps. So also, you need to know these definitions. We've talked about it on Quizlet. We've gotten on there, in class and as homework. You guys need to know these. You need to memorize a bunch of these definitions. Some of them aren't new. It's just the way we're saying them and defining them that's new. So, I underline that. It's pretty important. Okay, so I'm going to draw a 90-degree angle, and it says all right angles are congruent, so I actually need to have 2 because they're going to be congruent. So there's my little rough sketch of 2 90-degree angles. Okay, so I'm going to start off with that premise that I already start with, that my angles, we could name them ABC and LMN. That's what your book did. They have ABC as one angle. Or remember, you can also name an angle by its vertices. So we're going to have angle B and angle M, and they are right triangles. That's our given. Okay, we also know that both of them are 90 degrees. Their measure. Okay, so that's what the little m means. The measure of angle B equals 90, and the measure of angle M is 90. And that is the definition of a right angle. So now we can say they're equal. Their measures are equal. 90 equals 90. Okay, so we're still on equals. Alright, and this is the transitive property of equality. Now, be careful here because you might be tempted to put substitution, because you are substituting angle M for 90. I would accept substitution on a homework assignment or on a test or quiz, but transitive property is actually just a little bit more specific because we have that third part, angle M, angle B, and then 90 degrees. When you have 3 parts, you're not officially substituting. And then last, now that we have equal measures, we now know they are congruent. Okay, so we now know they're congruent, and this is definition of congruent angles. So we can jump from measures are equal to congruency by definition of congruent angles. Okay, you just proved that theorem. Okay, so the next one we're going to prove is theorem 6.3, which says supplements of congruent angles are congruent. Now, I already drew this picture on here for you because I want you to know what this is saying. This is saying if angle 1 and angle 2 are congruent, so my red angles that I drew on here, angle 1 and angle 2 are congruent, then their supplements, okay, which would be angle 3 and angle 4, are also congruent because together they equal 180. So angle 2 and angle 4 together, when we add them, equal 180. And angle 1 and angle 3, when I add those together, also equal 180. So that's my sketch. I can't fit it on with my statements and reasons on the next slide, so you might want to sketch that for yourself first before we move on. Okay, so where do we start? We draw a picture. That's where we started, right? Okay, so now we kind of have some information. We know that we are starting with two congruent angles, so that's what we have to establish first. And we also know they have supplements, okay? So we need to talk about that. So here's how I wrote it. Angle 1 and angle 2 are congruent. Angle 1 and angle 4 are supplements to each other, right? So angle 1 and angle 4 together are their measures are going to equal 180. And then angle 2 and angle 3 are also supplements, and that's our given. Okay, now I need to talk more about 1 and 2. Because they're congruent, I need to talk about their measures. So I'm going to say the measure of angle 1 and the measure of angle 2 are equal. And how do I go from congruency to equality? Definition of congruent angles. Okay. Now, I need to talk about addition. Okay, I need to talk about angle 1 plus angle 4 are going to equal 180, because that's what supplement means, right? But also angle 2 plus angle 3 equals 180. Now, if you separated these into two separate steps, again, not wrong, okay? It would totally be okay to do that. I am just a little bit lazy, and they're both the same reason, definition of supplementary angles, so I just put it in one step. Not a big deal if you separated it, okay? No, I just want to, this is like the perfect, remember I told you our examples in the book are perfect because they're the shortest amount of steps possible. Mathematicians are writing them. We've been doing it for a long time. So again, if you have some extra steps when you're struggling through this for the first time, please don't be frustrated. Okay, so now they're both equal. Both of these sets of angles are equal to 180. So now I can put them equal to each other. Their measures equal to each other. And what property did we just talk about on the previous one? If you said transitive, you are correct. So I'm putting the measures of angle 1 plus 4 equals the measures of 2 plus 3. Right? I'm getting rid of the 180 now. And that's my transitive property of equality. See all my abbreviations now. Alright, so now I'm almost there, because what is my goal? My goal is to say that the supplement angles are congruent to one another, right? I eventually want to have angle 4 and angle 3 are congruent. So I can now drop off 1 and 2 so that the measure of angle 4 and the measure of angle 3 equal each other, because 1 and 2 are the same measure. We just said that in step 2, okay? But how do I do that? How do I subtract off a measure? Okay, remember, there isn't a subtraction property. It is adding a negative. So there's only addition and multiplication. That's it. There's no division or subtraction property. So since I subtracted the measure, whatever that number happened to be, I subtracted it off, it's the addition property of equality. Now I have equals. I have them equals, so my next step is I can go straight from equals to congruency by definition of congruent angles. Okay, so I'm hoping that you're following along. I'm confident that everybody in this class can do these proofs. I'm 100% confident. I know that it's a little scary because it's different, but you'll be okay. We're going to do one more. Okay, this one is much the same as example 2, except they actually gave you a picture in the book. But I drew mine a little bit different, and I want to show you why. Okay, so here's my crazy picture. I have my vertex is X, and then I have ray XA, XB, XD, and XY, and then all of those angles in between. Okay, and it says my given isn't in there, right? I need to prove that the measure of angle AXB equals the measure of DXY. Now, it says if those measures are equal, then the bigger angles are equal. So I went ahead, the if part is our given. The then part is what we need to prove. So I marked the AXB and the DXY as being congruent, because isn't equality mean they're also congruent? It does. So that's why they're marked congruent. Now, what I want to prove are these black lines that I drew here. The AXD is congruent to BXY. So there's an overlap of that middle angle. And isn't that middle angle congruent to itself? So if we're looking at this picture, we should be able to come up with how it is even true. You know, you got to know that it's true before you can even prove anything. Okay? Alright, so let's first write our given. Okay, that's probably the easiest step of every proof, isn't it? Is to write the given. Okay, so now we know those measures are equal. So do I need to jump into congruency here? No, I don't, because the thing I'm trying to prove is actually measures are equal, so I don't have congruency in this proof at all. It's just one of those things I get to skip because of the nature of the proof. So, but what I do need to show is that if I add those two angles together, that they're equal to the other two that are added together. So AXB plus BXD equals BXD plus DXY. Okay, so I'm basically just adding BXD onto both sides. And what property says I can add? Yeah, addition property of equality. Okay, now I need to say what they're equal to. Okay, what measure are they equal to? So AXB plus BXD equals AXD, right? And then below BXD plus DXY, that equals BXY. Alright, you just follow me. All I did was say what the new angle would be if I added those together. And this is actually the angle addition postulate. Okay, so remember how I said you need to know those definitions? Okay, here's a postulate we will use a lot. You will see this a lot in this particular section. Okay, now since I already said the addition, the two sides of addition are equal to each other, can't I now just take out those additions? Can't I say that AXD is equal to BXY? Okay, and now this officially is substitution. Okay, and the reason for that is because you have an expression on one side with that plus sign. It's not a number. So if you put transitive here, I probably would have still given you credit for it, but I wanted to show you the difference between transitive and substitution. They're just so similar, it's easy to get them mixed up. So substitution, okay, so that's step 3 into step 2. That's what I'm really substituting. I'm doing 2 steps at the same time. Alright, so we're almost there. Now, let's rewrite our proof. If the measure of AXB equals the measure of DXY, which we said that was number 1, that was the given, then those two measures equal each other, which is what we said in step 4, and that is called the law of deduction. Okay, the last step, if you left off step 5, I would give you full credit for this proof because you did the if-then statement, you did the if in step 1, you did the then in step 4. To me, that's complete. The reason why they go the one more step is because we don't even know if those angles are equal measure. We don't know. We're not getting our protractor out and putting numbers in here. So we have to assume something first. Do you see how we're assuming those measures are equal? So the if-then statement is important to add on. Okay, so like I said, you're beginners. So right now I would give you credit, but when we get a couple more sections down the road, that's not going to fly anymore. Okay, so the rest of these are just theorems that you will need for other exercises. So this one you'll need for when we do number 8. The other ones are going to be 10, 15, 16, 17, and we actually won't even prove them, but I want you to know that they exist and put them in your notes. Okay, equivalence relation, we should know what that means. We should know that reflexive means it equals each other. Symmetric is if A and B, then B and A. And then transitive is that one that we get all tripped up with because it's sort of like substitution. Adjacent angle sum theorem. Okay, these will be on quizzes and tests, but you won't have to prove them in the homework today or tomorrow in class. Same with the adjacent angle portion theorem. Just be aware that it exists. And last, the congruent angle bisector theorem. This is exactly like the segment bisector theorem. Okay, so if two angles are congruent and you bisect both of them, then all four angles are congruent, just like the segments. Okay, so your whisk summary. You are going to draw or sketch the following figures and write any conclusions you can come up with. That's for numbers 1 and 2. I didn't separate this very well, so I'm hoping you're listening. So for 1 and 2, you're going to draw the angles with the appropriate things there, and then try to come up with conclusions that you can come up with. Number 3 is actually half of a proof. Okay, so number 3, if you look exercises 1 through 6 on page 218, they give you the statement, and I need you to come up with the reason. Number 1 is a reason for the first statement. Number 2 is the reason for the second statement, and the whole proof is 6 steps. So I need you to come up with that as best you can. Again, you're not being graded on right and wrong. This is for completion. I need effort. Do your best, and I'll see you in class.